Okay, hi everybody. I'm just giving you a quick review of atomic radius trends on the periodic table. I've marked it out on the periodic table here. The atomic radius increases as you go down a group, and the atomic radius increases on the periodic table as you go from right to left across a period. Okay, remember periods are rows and groups are columns. Now, I've written down a quick explanation here of why the atomic radius increases as you go across from right to left on the periodic table. Even though lithium has 3 electrons and neon has 10 electrons, you expect neon to be bigger. It's not. So here are the electron configurations of all second period elements written down here. The red box is around the coelectrons of each element. Okay, remember coelectrons are the electrons that are not the valence electrons, and valence electrons are the electrons in the highest energy level of each element. And for second period elements, the highest energy level is the second energy level. So I've written down all of the valence electrons in purple. Okay, the coelectrons are written in red. So you can see as you go from lithium to neon across the second period that the number of coelectrons stay the same. So I've written it down here. Across a period, the number of coelectrons stay the same. And then if you look at this column here that says nuclear charge, you'll see that as you go across from lithium to neon, the nuclear charge or the positive attraction of the nucleus is increasing in all of these elements. Okay, so lithium has a +3 nucleus and neon has a +10 nucleus. Because neon has 10 protons, it's a +10 nucleus. So the role of coelectrons in an atom is to shield the valence electrons from feeling the full charge of the nucleus. So think of it as coelectrons standing between the nucleus and the valence electrons, helping to shield the valence electrons from feeling that full charge of the nucleus. So they stand between the valence and the nucleus. Okay, so what happens is I've taken out two of the elements so we can compare. The shielding changes the amount of attraction felt by the valence electrons. So in lithium, which has a nuclear charge of +3, the coelectrons are a -2 because each electron has a -1 charge, and there are two coelectrons. The coelectrons cancel out two of the plus charges of the nucleus. So the valence electron of lithium only feels a +1 charge. In neon, the nuclear charge is +10. It has the same number of coelectrons so as lithium. So neon's nucleus, if you cancel out two of the plus charges, all of the valence electrons in neon feels a +8 attraction. Okay, so because of that, neon's valence electrons are more attracted to the nucleus and therefore move closer to the nucleus, resulting in smaller atomic radii. Okay, so let's read the reasons out again. Across a period, the number of coelectrons stay the same. We can see it here in red, the red box. The coelectrons are the same. Across a period, the nuclear charge of atoms increase. That we can see as well. Starting from lithium going down to neon, the nuclear charge is increasing. Because the core stays the same, but the nuclear charge increases, the valence electrons of elements to the right of the periodic table are held more tightly, resulting in smaller radii. So neon's electrons are far more attracted to the nucleus because neon's valence electrons feel a +8 attraction compared to lithium's +1 attraction, which results in neon's electrons moving closer to the nucleus, like a moth to flame. Okay, electrons move closer, resulting in the atom becoming smaller, and therefore neon has a smaller atomic radius. Okay,